Okay, so we are going to go over the last notes for acceleration. This is going to be how do you draw a velocity time graph from a distance time graph and vice versa. So they correlate together. So first we're going to talk about how do you get a velocity time graph from the distance time graph. We're going to go over the same three questions that we've been working with to analyze these graphs. Direction the object moves, what's happening to velocity, and then the acceleration. So the first thing you want to do is indicate the direction the object is traveling, toward the origin or away. If the object is traveling away from the origin on a distance time graph, that means it has a positive velocity, or v plus, which corresponds to the positive quadrant on a velocity time graph. If it's moving towards the origin, it has a negative velocity, which corresponds to the v minus on the velocity time graph. Indicate what's happening to velocity. Is it increasing, decreasing, constant, or no motion? Remember, for the increasing and decreasing, pay attention to the more vertical parts of the curve and the more horizontal. More vertical means fast, more horizontal means slow. Before you get to the acceleration, draw the graph for the velocity time. It's going to be so much easier to indicate the acceleration if you draw the graph first, because then you can just look at the slope. And once you draw that graph for the velocity time graph, then you can indicate the acceleration as a positive, negative, or zero. Remember, a zero acceleration means the object has a constant velocity. All right, so let's actually go through this graph on the left-hand side here. The object is moving away from the origin, so when I draw my velocity time graph, I need to draw it in the positive quadrant. My graph on the distance time is from fast, more vertical, to slow, more horizontal. So fast to slow, I am slowing down, or velocity is decreasing. So when I draw my graph, I want to make sure I'm drawing the graph towards the zero mark, okay? Towards rest or stop. So then my graph would look like this. I start at a value and go to zero. And then I can see my slope. My slope is negative, drawn downward, so my acceleration is negative. So you're answering these same three questions that we've been working with to draw the graph. So then this graph will correlate to this velocity time graph. So these two correlate together. Next, we're going to do the opposite. So we're going to start with a velocity time graph and then draw the distance time graph from it. Same thing. We're indicating the direction of motion first. This time, to indicate direction, it's where the graph is drawn. So is it drawn in the positive quadrant, okay, up here, which means away from the origin? Whoa, that went fast. Or is it drawn in the negative velocity quadrant, which means towards the origin? So for the direction of motion, you're looking at where that graph is drawn. Then tell me what's happening to velocity. Increasing velocity will start at zero and go to a value, whether that's positive or negative. Decreasing velocity will end at zero. Constant velocity on a velocity time graph is a horizontal line. Both quadrants, horizontal line. No motion means the velocity is at zero, so the line would be drawn across on this x-axis. Then tell me the slope. Is it positive, negative, or zero? A zero slope means a horizontal line. The object has a constant velocity, zero slope. It's positive drawn up or negative drawn down. That would be your acceleration. So my direction of my object is away from the origin because it is drawn in the positive quadrant. Not how it's drawn, but where it's drawn. Velocity is increasing. This line starts at 0, meaning we're starting at rest or we're stopped. And then we go to some value, obviously we'd be speeding up. And finally, acceleration is positive because the slope is positive. So to draw my distance time graph, I need to know 1 and 2. Number 3 really can't help me draw the graph because I physically cannot see the slope for acceleration on a distance time graph. I can't see it. I know if it's there, however, I can't see it. So the 1 and 2 are very important to draw a distance time graph. So I need to draw it away from the origin and increasing speed. So my curve is going to look like this. Slow to fast, so I'm increasing away from the origin. So this distance time graph correlates with this velocity time graph. When you practice these enough, you will start to see the correlation between the two. This one only goes to this graph, okay? Work on the practice answering these questions.